Before we jump into kind of the formula pieces, we'll talk about, we have names for parts of our cone. A lot of them are pretty self-explanatory, like base of a cone. We know what a base is of a figure. It's always going to be a circle. We call our peak of our cone, or our point, we would say, our vertex. Lateral surface, the surface like around the cone, the curved area. The two big ones that we have to pay attention to and make sure we really don't mix up are slant height and regular height. So these two. Slant height. Nope, I don't want to. Slant height and regular height. Regular height is kind of what we used for when we were doing volume and whatnot. Just from the base to the highest point, that's our regular height. And then our slant height is, think of it like the diagonal length of the outside of the cone. One formula for surface area, we use slant height. And for volume, we use regular height. And that's kind of the big, probably going to be the biggest thing, just making sure you're using the right one. So we're going to start off with surface area. So the formula for surface area, we use S, capital S, and it's pi r squared plus pi rl, where L is our slant height and R is the radius. You can write like a normal L, or you'll see a lot of times it's written as a kind of a cursive L. The pi r squared part, this is like the surface area of your base, because it's a circle. Pi r squared, we know that's the area of a circle. And the pi radius times our slant height is the area of the lateral surface. So if we add those two together, we get the surface of the whole thing. So just like we've been doing the last few days, there's not a lot of glitz and glams to this. It's find your numbers, plug them in, do the calculations. So we're finding the surface area of these two right cones. We're not given a picture, we're just given information, but that's all we need. So your surface area, just copying so I don't have to back and forth. The surface area is pi r squared plus pi r l. And again, it doesn't matter for at least these ones what order they're written in, especially when we're multiplying them, since multiplication, order and multiplication doesn't matter. But let's just plug in what we know. Pi is pi, our radius is 4, so this would be 4 squared, plus pi times 4, our radius times our slant height, 6. And this maybe you would call like an intermediate step. I would kind of expect that most of us could do this in our head. Not most of us, I know all of you can do it in your head. So you may not have to write this step out. I'm just showing it so we can get used to the formula. 4 squared is 16, so we have 16 pi. Plus 6 times 4 is 24, so we have 24 pi. And when you're adding numbers that both have a pi on them, you could just add the actual digits, so 16 and 24, and keep the pi with it. So just add these two numbers together. So 16 plus 24 is 40. So this is equal to 40 pi. So this is what we would call our exact answer. But on big ideas, they always want it rounded to the nearest hundredth. So then on your calculator, you just do 40 pi. Which I may already have it on here. No, I didn't. I erased it. 40 pi is 125.66. 125.66. And now you have to remember we're talking about area. So units are important. So since area is units squared, this would be inches squared. IN squared. So both of these would be good answers depending on what it's asking for. Example B, if you want to give it a shot on your own, don't feel like you have to wait up for me. It's same deal. We're just going to plug in what we know and go from there. It'll be our surface area is equal to our pi times our radius squared. So that's 8 squared plus pi times our radius times our slant height. Again, here it's just a regular L and not the cursive L, but L is for slant height, H is for regular height. Uh, 8 squared is 64, so you have 64 pi plus 80 pi. Should give us 144 pi. Again, I'm combining, just adding 64 and 80, adding them together. And then we have to find our exact answer would be 144 pi. That we want to approximate an answer. 144 second pi. 452.39. And this will be, we're still in inches, and it's area still, so inches squared. So the only other time, like the only other formula that we'll learn for a surface area is on Monday we'll do spheres. Because everything else we could figure out by, like if you had a triangular pyramid, it's all made up of just different triangles. For that, you would just add all your areas of your triangles separately together. This, since it's a curved surface, we have a special formula for it. Same thing like a sphere, since that's curved, it has its own formula. Pretty straightforward. Volume of the cone, same deal as really with cylinders, because the volume of a cone is 1/3 times the base times the height, where your B stands for the area of your base, and now H is our regular height of our cone, so not our slant height. And B, we can always use pi r squared instead of B, because our base of our cone will always be a circle. If it's not a circle, then it's not a cone. These problems are kind of just like how we've been dealing with all these formulas that kind of just plug and go in. On the second example, you'll see already it gives us the slant height and not the actual height. That's really about as like complex as these problems get, as you have to find like something that's not given to plug into the formula. But we'll get there when we get there. We'll do example 2A to start. Again, this is just another nice using your formula. Volume is, don't forget the 1/3. That's what I find myself. If I try to do this quick, I forget the 1/3 part. 1/3 base times height. And then we can write 1/3. If you want to substitute your base in all at once and not do a separate calculation, your base is pi r squared. So it's 7 squared times pi times h, which is 13. We know this is our regular height because it's not kind of written across here. It's clearly going from the base to the peak. So this would be 1/3 times 49 pi times 13. And as I did yesterday, I said I like to multiply these two numbers first before I divide by 3, just to save. I think it's easier that way. Multiplying by 1/3 is never fun, so I divide by 3. So I'm going to take 49 pi times 13. So then I could write that as, if I just take 49 times 13, that's 637. So this is 637 pi. So if you just take then 637 pi, divide that by 3, you get out 667 point, this would be 0.5, and now we're back in the world of volumes, so our units are cubic, so this would be inches cubed. If you were typing this, I always like to show, because each calculator is different and there's like little nuances that you just get as you practice more with the calculator. If you're dividing this, so if you want to do it all in your calculator at once, this top part has to be in parentheses and then you have to do divide by 3. Or you could just you could get this number first and then just hit divide by 3 and you'll get the same thing. This would just give you a long decimal, so it's good to use that like answer key. So it just plops in what you already have. All right, last example. Again, finding more volumes. But as I said, this 8 meters is our slant height L. And to find volume, we need our H value, which would be that length there. So we sometimes call these right cones because inside of this cone we can make a right triangle, which is going to help us solve for H. So on your paper, you don't have to do this, but you can kind of bold in and see, okay, well, that's a right triangle right there, where the hypotenuse is kind of the length of the slant height. One leg is the radius, the other leg is the height. I'm going to draw this red triangle off to the side. It's like the worst triangle I've ever drawn. Oh my god, I redo that. It's better. So this side is 5. Our hypotenuse is 8. And we don't know this leg. H is what we're trying to find. So whenever you're trying to find the side length or a leg length of a right triangle, you can use Pythagorean's theorem. So your hypotenuse squared is equal to one leg squared plus the other leg squared. So with our values that we have, that would be 8 squared is equal to our one leg, 5 squared, plus our second leg squared, H squared. 8 squared is 64. 5 squared is 25. Now it's just we're trying to get H by itself so we can have a value to plug into our formula. So 25 minus 64 is 39. So we have H squared is equal to 39. And then we just want one of the H's. We don't want H squared. So we got to take the square root of both sides. Here. So H is equal to the square root of 39. And this, again, it's not a perfect square, so if you do this on your calculator, you get out a long decimal. To get the most approximate answer, I would just plug in square root of 39 into your volume formula. So I'm not going to get that as a decimal with any rounding. I'm just going to label H is equal to the square root of 39. We'll plug that in for H for our volume formula. So our volume is equal to 1/3 of our base, which is pi r squared. Our radius is 5. So this would be 5 squared pi times our actual height, which is the square root of 39. I know, we're tight. Sorry, you're tight on space. I tried to fit everything in one page. Seems silly just have 2 problems on the back side. All right. Multiplying this through, doing some more simplification. 1/3, 25 pi, square root of 39. We can then multiply our two numbers in parentheses together. But since this is not a root and this is a root, you can't multiply 25 pi and 39. We write it as 25 pi times a square root of 39. So just one more simplification step. And you can type this piece highlighted in yellow. You can type it into your calculator just like that, and then hit your divide by 3 button. So 25 pi times a square root of 39, you get 490.4809958. And then we split that into thirds, so we divide by 3. And you get out approximately, rounding to the nearest hundredth again, 163.49, and then what are our units? Meters. So we're in meters cubed. This, since we didn't round here, and we kept in our exact value for h all the way through, this is like as close as approximating as we can get. So good with minimal error in there.